Myself Dr. Sriparna Saha, and currently we are talking about different parameters of genetic algorithms. So what we have discussed so far? We have discussed how to generate the initial population. Then we have talked about how to calculate the fitness function. Then after that, if the current population doesn't converge, then what do we need to do? We need to select the best fitted population. So how the selection can be done? There are different techniques of selection that are done or that have been covered in a separate video. You can check the video for detailed description. Now we have come to the reproduction stage, and in the reproduction there are two processes called crossover and mutation. So currently or in this particular lecture we are going to talk about crossover techniques. So the crossover. So why to do the crossover? So what was the aim of selection? Selection is done to identify the best fitted population from the mating pool. So after selecting the best fitted genes, we need to go for the child population. And what is our aim? To get much more fitter population. So that is why to get much more fitter and diverse set of population, we are going to do the crossover. So using crossover, we can go to a random state whose fitness value should have been higher than the parent population. That is, random exploration of search space can be done using crossover. So for the crossover, we need to decide the crossover point. This is also known as K point. The value of K can be between 1 and L, where L is the length of the chromosome. In this picture you can see that is the length of the chromosome has been marked by L, and where we are doing the crossover, that is denoted by the K point. So if the parent population or the two parents are in this fashion as given in this particular picture, so the crossover result becomes 0 0 0 0, then all the ones. If the crossover is done after the fourth point from the left side. So for the binary coded GA, so what are binary coded GA? That has been discussed in the encoding techniques of GA. So just recapitulate. So binary means the chromosome will be encoded by only 0 and 1. And in this lecture series we are going to talk about only the crossover techniques that are possible in binary coded GA. There are mainly 8 different crossover techniques, namely single point, 2-point, multi-point, uniform, half uniform, shuffle, matrix and 3-parent crossover. Now just look at the first crossover technique, that is single point crossover. As the name suggests, so there will be only one K point. Suppose here the K point is after the third point from the left side. So the child population value becomes 001 from the first parent gene, and then taking 11010 from the second parent gene. Similar way, taking the right side from the crossover point from the second parent gene, combining with the left side from the crossover point from the first parent gene, is going to give us the child population. So there are basically two child are formed, and the second child value becomes 101010000. So what we are doing, that is we are combining the left portion from one parent gene with the right portion from the another parent gene based on the crossover point, and this is a vice versa thing. you can understand this point, then you can easily understand 2-point crossover. So 2-point means there will be two crossover points or 2k points. Here the 2k points are ki and kj, and these two values, that is ki and kj, should not be equal. If they equal, then the crossover becomes single point crossover. So for the 2-point crossover, the ki and kj values should not be equal. Now the child population value becomes 0 0 from the first parent gene, then 1 1 1 0 from the second parent gene, then again taking the values 0 0 from first parent gene. Similar way, 1 0 1 1 1 0 1 0 is the value of the second child population. This is 2-point crossover. Now if the crossover points become more than 2, then it becomes a multi-point crossover, and ki, kj and kl values should not be equal, otherwise they can be single point or multi-point single point or 2-point crossover. So for the multi-point crossover, there will be at least 3 crossover points. You can easily understand from the figure how the child population chromosome values have been decided, taking the portions from the two parents. So this is the multi-point crossover. Now the uniform crossover, or it is abbreviated as UX. Here basically a toss is done. If the result of the toss is 1, then parent gene is selected, that is parent 1 gene is selected. If the toss result is 0, parent 2 gene is selected. Suppose we have tossed, and how many times we have to do the tossing? Based on the length of the chromosome. Here the length of the chromosome is 8, so we have to do 8 tossing. And in this 8 tossing, suppose the result is 1 0 1 0 0 0 1 1. Right? Now if the result is 1, then we are taking the value from the first parent gene, that is the child value becomes 0. Then the toss value is 0. So for the first child, we are going to take the value from the second parent. So value becomes 0. Similar thing has been done. You can pause the video and check how the UX crossover is done over here. After that, we are moving to the half uniform crossover, or HUX. So in the uniform crossover, we have done a tossing. Here also we are going to do a tossing, and based on the tossing we are going to swap the values from the two parents. But here the concept is, that is how many times we are going to do the tossing. This uniform crossover, we are going to do the tossing for how many points are there in the chromosome, that is based on the length of the chromosome, but here that is based on the Hamming distance. What is Hamming distance? Hamming distance is the difference of values between two genes, and Hamming distance have applications in different coding techniques. So suppose the two parent gene values are 0 0 1 1 1 0 0 0, and the second parent gene is 1 0 1 1 1 0 1 0. So how many bit position they are different? They are different at the first bit position, and they are different at the 7th bit position, right? So that is, we are going to do twice the tossing, that is based on the Hamming distance of 2. So in that tossing, suppose one result is 1. So if the result is 1 of the 1 from the toss, then we are going to swap the values between the two parent genes. And if the toss result is 0, then there will be no tossing. This is half uniform crossover. Again, just pause the video and understand how it has been done. Next we have came to the shuffle crossover. So in that shuffle crossover, from the parent gene, first we need to do the shuffling. But shuffling will be based on the crossover point. That is, the values present at the left side of the crossover point for any parent gene will be shuffled among them, and the values present at the right side for one particular parent gene based on the crossover point will be shuffled between them. You can check the shuffling. After the shuffling, based on the K point, the crossover is done. And remember one thing, shuffling is not done between all the bits that is present in the parent gene, but based on the crossover point, that is the values present at the left side will be shuffled among them, and same thing has been done for the right side as well. So this is all about shuffle crossover. Next we are moving to the matrix crossover. So the parent gene first need to be represented in the matrix format. Suppose the length of the parent gene is 1 row and 8 columns. So we can represent in the matrix format of 2 rows and 4 columns, right? Same thing has been done for the second parent as well. Next, from the matrix we need to decide some non-overlapping zones. That is, matrices are divided into non-overlapping zones. Between the non-overlapping zones we need to do the crossover. You can see in this particular image, that is how the crossover is done based on the zones, right? Just pause the video, then you can easily understand how this crossover is done. Just check it. Then after that, the zone division has been done and we have done the crossover. Now it is time to represent the child population similar length size, that is parent population. Just check the parent population, it was 1 row and 8 columns. So the child population should also have 1 row and 8 column. So similar way this matrix has been put into array of 1 row and 8 columns. So this was the parent population, and after matrix crossover this is the child population. This is all about matrix crossover. Next it is the 3 parent crossover. So 3 parent means there will be 3 parent population will be take part in the crossover. So in the child population obviously there will be values taken from 3 parent. Just see, that is how the 3 parent values have been combined to form one particular child population. Now this third parent can sometimes be taken as a toss result. Which toss result? Just check this particular slide, that is the uniform crossover. For this uniform crossover, that was the toss result was of size of 8, right? So suppose this particular toss result is one particular parent, that is the third parent. So based on the third parent or based on that result and this particular time, that is the toss result, that can be done the crossover, that is the third present, the third parent, where that has been represented in the blue lines, that is dark blue. Here the values can be the result of the toss, it is assumed as the toss result. So based on the toss result, crossover can be done, that is known as 3 parent crossover. And in the 3 parent crossover, how many children should be there? Just to understand, in the 2 parent we are going to get 2 child population. So 3 parent, 3 child population should be there, and I have given the result for only 1 child. So there will be other 2 child. So that is kept as an exercise for you. Just do it. So thank you everyone. I hope you understood today's lecture. If not, then please give a comment over here, and happy studying.